Great, so this video is on units in dimensional analysis, that topic where we talked about experimental design and did the beaker basket stuff and the graphing with the cars and all that sorts of stuff. So this is kind of looking at experimental design, interpreting graphs, making up experiments. So we want to be able to identify the independent, the dependent, and the control variables. The independent variable is the variable that you are changing on purpose, the one that you're manipulating. The dependent variable is the one that you're measuring, that you're not in control of, all right? This is the one where you're kind of seeing the outcome. And then control variables are other things that you are going to do the same for each trial to make sure that they aren't affecting the outcome and that the only thing that's being affected is that dependent variable. So for this first example, you're curious about the effect that nutrition has on your muscle gains in a weight training program. You decide to add 10 grams of protein to your diet each day. Okay, so that's what we're changing, right? Without changing the rest of your normal diet, so that's something we're controlling. And then we're going to measure increased strength at the end of 2 weeks as you normally do and compare it to the previous 2 weeks gains. So that's another thing that you're kind of keeping the same, which is that you're measuring your strength gains on the same timeline. So what we're changing on purpose is the 10 grams of protein. What we are monitoring is the increase, so that's 10 grams of protein is the independent, increase in strength is the dependent, and then you aren't changing the rest of your diet, and you're measuring your strength at the normal 2-week interval. So that's that. We want to be able to look at graphs and kind of have a general idea of what is happening in them. So we want to be able to plot experimental data. Remember that our intervals when we make graphs are always consistent. So if we have to scale this, this is an example, number of math problems solved versus hours away from a meal. So when this was set up, I needed to go all the way to 4, so each line I have, 3 lines, so each line's being worth 1. 4 lines. It's a little different on the computer program. But so important thing that each interval is consistent because that gives us a relationship that we can interpret. So number of math problems, hours away from a meal, we can see, okay, as time is going by, what's happening? Well, the number of problems that we are able to solve is increasing. And so as we are getting closer to the meal, coming this way, we can see that we're not able to solve as many problems. So the independent variable always goes on the x-axis. That is frequently time. If we're using a line graph, it's whatever we're in control of that we are changing on purpose. The dependent is what we're interested in, what we're measuring. So this would be the independent would be hours away from the meal, dependent how many math problems people could solve. And we can see that as we are getting further away from the meal, people are able to do more, is what that graph is showing. All right, the other section that we looked at when we did experimental design, we started talking about dimensional analysis, and I wanted to do one of these problems, even though, we kind of talked about this in class Monday. I want to just do another one of these examples and kind of talk about, when you're doing these problems, remembering those 3 steps. So first off, my first step, let's go ahead and do number 5. First step is reading through the problem and anything that is a conversion factor, writing it down. So current exchange rate for money between US dollars and Canada is that 3/4 of a US dollar is 1 Canadian dollar. Okay, so that is a conversion factor 0.74 US dollars, which I'm going to abbreviate USD, is equal to 1 Canadian dollar. Be right back. Great, continuing to read. I see that I have 40 US dollars, okay, And a dish of poutine, the Canadian national dish, costs 13 Canadian dollars. Okay, so that second part there, a dish costs $13. That is another conversion factor. One dish of poutine is 13 Canadian dollars. So one poutine is 13 Canadian dollars. Right. How many dishes? So we're getting to the question part now, right? So we're reminding ourselves, first thing we do, write down this conversion factor. Second thing you do, go to the question and try and figure out where you're starting and where you're going to. So if we read the question, how many dishes of poutine can you buy with the money you have? Okay, well, what money do I have? I have 40 US dollars. So I have 40 US dollars. And I'm trying to figure out how many dishes of poutine I can get. So starting with $40 and going from there. So $40, 40 US dollars. I'm trying to get to poutine. Well, I need to first get rid of US dollars. So I'm going to be putting it here for it to cancel out. 1 Canadian dollar goes on top. Oh, and then 13 Canadian dollars, this one here, get us one thing of poutine. Alright, so it turns out that I'm going to be multiplying 40 by 1 and 1 and dividing by 0.74 times 13. Alrighty, when you do that math, you find that you could get 18 dishes of poutine, right? 18.01 dishes. And, 18.01, well, we can't really have 0.01, and it's not enough to get us to 19 dishes, so most reasonable answer would be 18 dishes. And who knows, maybe you want to get a t-shirt or some sort of other Canadian delicacy, but you now know roughly like what amount you can get for the money you have, and that's the beauty of being able to do dimensional analysis. It doesn't just help us in chemistry; it can help us quite a bit in a surprising variety of life problems. So this is that section on units and dimensional analysis, and I'm going to go ahead and end it there.